The last thing I would like to take a look at here is the fact that we could fit exponential functions to data. In other words, we could do exponential regression. We do exponential regression exactly the same way that we do linear regression or quadratic regression. Now, I left out a few steps and calculator buttons, but if you feel comfortable with linear regression, the only difference is when we go to choose the type of regression is that we actually would pick exp regression. But just like we did before, we would enter the data. We might want to draw a scatter plot. Again, it's not a necessary piece if we just want the regression equation. And then we would do the exponential regression. And you'll notice if I did exponential regression, it actually tells me the formula it's using is y equals a times b to the x. And once it does the regression, it tells me that my a is 24.512, and it tells me my b is 1.0147. And then it does, since I've turned on my diagnostics, it does tell me not only an r, but an r squared. And you'll notice that my r ends up being 0.896. Again, like we did with linear, the closer this is to 1, the better the data models an exponential function. So this models it reasonably well. It's not a beautiful modeling, but even if we take a look at the scatter plot, we notice that the data doesn't look like it's a perfect exponential. In fact, if you looked at it, some of you might say it looks almost cubic because it has this kind of almost an S type of shape to go with it. So you'll be asked to do a couple of questions in the book that'll have you do exponential regression. You can actually check your solve equation or solve and find exponential function formulas using this, but I will be expecting that you're able to find exponential functions, exponential formulas completely by hand, and that I'll need to see an algebraic solution. But this could be a way of checking your answers.